Modulus Inequalities.
So, in this video, I am going to show you how to solve modulus inequalities where modulus f of x is greater than or less than a constant k. Since this video is related to the previous video, rational inequalities, if you are new here, you can click on the link on top here to follow my tutorial about how to solve rational inequalities before you continue in this video. Make sure you hit the subscribe button below to subscribe my channel because my next video is going to show you how to solve other types of modulus inequalities. If you are happy with the video, please give me a thumbs up and hope to see you in next video. Thank you so much. Today in this video, I am going to talk about how to solve the modulus inequalities where modulus of f of x is greater than or less than a constant. Now generally, when modulus f of x less than k, it is same as f of x greater than or equal to negative k and at the same time less than positive k. When modulus f of x greater than k, it is either f of x less than or equal to negative k or f of x greater than or equal to positive k. But many students always make a common mistake, that is, they always combine these two inequalities becomes negative k greater than f of x and also greater than positive k. So this is definitely not correct. Now let's try this modulus inequality. Modulus 2x plus 1 less than 11. So before we can solve the inequality, first we need to clear this modulus sign. So when we clear this modulus sign, we can replace with this interval where we will get 2x plus 1 greater than or equal to negative 11 and less than or equal to 11. Then we can shift the positive out to the left hand side and also to the right hand side. Becomes 2x greater than negative 12 and less than 10. Then we shift the 2 up to the left and to the right, becomes x greater than or equal to negative 6 and less than or equal to 5. Then the solution of this inequality must be written in set notation form, which is x is greater than negative 6 and less than positive 5. Next, when modulus 2x plus 1 is greater than or equal to 11, then after taking away the modulus sign, it becomes 2x plus 1 less than or equal to negative 11 or 2x plus 1 greater than or equal to 11. Now we try to simplify each inequality. So for the inequality on the left hand side, after simplify, we found that x is less than or equal to negative 6. For the other side, after simplify, we found that x is greater than or equal to positive 5. Same thing, the final solution for the inequality must be written in set notation form. So therefore, x is less than -6 or equal to -6, or x is greater than 5 or equal to 5. Now let's try this modulus inequality. Since the modulus is less than 2, means when we take away the modulus sign, it becomes greater than -2 and less than 2. But when we look at this function, since this function is not linear, so means we are not able to solve this inequality directly. So instead of that, we need to separate this inequality into two. First one is the inequality on the left hand side. That is -2 less than x power 2 plus x minus 4. The second one is on the right hand side. That is x power 2 plus x minus 4, which is less than 2. Then, because this inequality is greater than -2 and at the same time it is less than 2, so the conjunction that we use here, it is AND. Now what we need to do is we need to solve these two inequalities separately. So first, we try to change the position where x power 2 plus x minus 4 becomes greater than -2. Then we shift all the terms to the left hand side. Then we factorize the quadratic. Becomes x plus 2 multiply x minus 1. To find this inequality, now we need to sketch the quadratic, the U shape, and we label the part of the graph which is on top because greater than. So from here, we can get the inequality as x less than -2 or x greater than +1. So this is the first part of the inequality. Now we go to second inequality. Same thing, first we shift all the terms to the left hand side. Then we factorize the quadratic. We get x plus 3 multiply x minus 2. Same thing, we sketch the U shape for this quadratic. And since it is less than, so we shade the region on the below the x-axis. So therefore, the inequality for x is x greater than -3 and less than 2. So this is the second inequality. Now we need to combine these two inequality by using AND. So first, we use a number line to help us. So first we mark the critical value, -3, -2, 1, and 2. Now for the first inequality, x less than -2 and x greater than 1. Then for second inequality, x between -3 up to +2. Since the conjunction is AND, so means we need to take the section which consists of two arrow lines. That is from -3 up to -2. and from 1 to 2. So therefore the solution for this inequality is the value of x from -3 up to -2, and also from 1 up to 2. Now, in case the inequality is greater than 2, so when we take away the modulus sign, so the inequality becomes x power 2 plus x minus 4 less than -2, or x power 2 plus x minus 4 greater than 2. Now we need to solve these two inequalities separately. Okay, same thing. We shift all the terms to the left hand side. Then we do the factorization for this quadratic. Then by using the U shape of this quadratic, we try to identify the interval value of x. Since it is less than 0, so x is in between -2 up to 1. So this is the first interval for x. Next, we go to the second inequality. First, we try to simplify the inequality by shifting all the terms to the left. Then we factorize the quadratic. Then by using the U shape of the quadratic, we find that since it is greater than 0, so we find that the x is less than -3, or x is greater than 2. So this is second inequality. Now we need to combine these two inequality by using the conjunction OR. So first we need to use the number line to help us to combine these two inequality. So first we mark the critical point, -3, -2, 1, and 2. Now for the first inequality, x is in between -2 up to 1. The second one is x less than -3 and x greater than 2. Since we combine by using OR, so means we will take all the section which consists of the arrow line. So therefore, the solution for this modulus inequality is x less than -3, or x in between -2 up to 1, or x greater than 2. Now let's look at this modulus inequality of rational function. Since it is less than 1, so means when we take away the modulus sign, we will get one is greater than -1, the other one is less than +1. And we are not able to solve this inequality directly, so we separate into left hand side greater than -1, and on the right hand side less than +1. And because of this function is greater than -1 and at the same time less than +1, so therefore the conjunction is AND. So now we solve the inequalities separately. So first we change the position so that the function is on the left hand side, and we try to shift all the terms to the left hand side, becomes plus 1. Then we need to simplify all the terms on the left hand side, becomes single fraction. So first x plus 1 plus 3x minus 5. So we got 4x minus 4 over 3x minus 5 greater than 0. Then we factorize the 4. So becomes 4x minus 1 divided by 3x minus 5 greater than 0. Now, in order to find the set of value of x in this inequality, first we use a number line to help us, and we try to mark the number line with the critical point. Now, the critical point is the values of x where x minus 1 equals 0 or 3x minus 5 equals 0. So that's x equals 1 and x equals 5 over 3. So now we need to test x minus 1 and also 3x minus 5 in each of these sections. Now we test x minus 1 in each of these sections. So for the first section where x is less than 1, we find that x minus 1 is a negative value. When x is negative 1 up to 5 over 3, x minus 1 is positive value. And when x is greater than 5 over 3, we found that x minus 1 is positive. Now we test the 3x minus 5. So for the first section when x less than 1, we found that 3x minus 5 is negative. Then when x is in between 1 to 5 over 3, 3x minus 5 is negative. For x greater than 5 over 3, 3x minus 5 is positive. Now we need to combine in order to get the final result. Now for the region x less than 1, we found that it is positive. From 1 to 5 over 3, negative. Greater than 5 over 3, positive. Now because the inequality is greater than 0, means we need to take the section which is positive. So therefore the set of value of x in this inequality is when x is less than 1 or when x is greater than 5 over 3. Now we continue to the second part where x plus 1 over 3x minus 5 is less than 1. So same thing, we shift all the terms to the left and we try to simplify the expression on the left hand side into single function. So after simplify, we found that we will get 6 minus 2x over 3x minus 5 less than 0. Now we factorize 2, then we get 2 multiplying 3 minus x over 3x minus 5 less than 0. Now same as before, we try to mark a number line with critical point where the critical points are the values of x where 3 minus x is equal to 0 and 3x minus 5 is equal to 0. That is 5 over 3 and 3. Then after that, same thing, we need to test 3 minus x and 3x minus 5 in each section. So first we test 3 minus x. When x is less than 5 over 3, 3 minus x is positive. When x is in between 5 over 3 up to 3, 3x minus x is positive. When x is greater than 3, 3 minus x is negative. Now we test 3x minus 5. When x less than 5 over 3, it is negative. X between 5 over 3 up to 3, it is positive. X greater than 3, it is positive. So now we combine in order to get the final result. So when x is less than 5 over 3, we get negative. When x is in between 5 over 3 up to 3, positive. When x greater than 3, it is negative. So since the inequality is less than 0, means we need to take the section which is negative. So therefore, x is less than 5 over 3 or x is greater than 3. So this is second part of the inequality. Now we need to combine this set of value of x by using AND. First we use the number line and we try to mark the number line with all the critical point of this set of value of x. So first one is 1 followed by 5 over 3 and 3. So for the first set of value of x, x less than 1, then x greater than 5 over 3, followed by second set of x where x less than 5 over 3 and x greater than 3. Since we combine by using AND, means the section which consists of two arrow lines, that is the section that we are going to take. So in this diagram we can see that that is when x less than 1 and also when x greater than 3. Therefore, the solution is x is less than 1 or x is greater than 3. Now, in case the modulus inequality is greater than 1, and when we take away the modulus sign, here we will get x plus 1 over 3, x minus 5 less than 1, or x plus 1 over 3, x minus 5 greater than 1. So same thing, we need to solve each of these inequalities separately. So for the first one, we try to shift negative to the left hand side becomes positive, then we simplify the terms on the left hand side becomes a single fraction. So after simplify, we found that it is 4x minus 4 over 3x minus 5. Now we factorize the 4, becomes 4 multiply x minus 1 over 3x minus 5 less than 0. Now based on this table just now, we found that the set of value of x for less than 0 is the section produce negative. So therefore, the set of value of x for this inequality is when x is greater than 1 up to 5/3. Next, we go to the second part of the inequality. So same step, we shift 1 to the left hand side becomes minus, then we try to simplify the fraction. Then we get 6 minus 2x over 3x minus 5 greater than 0. Then we factorize the 2, becomes 2 multiplying 3 minus x over 3x minus 5 greater than 0. Same thing based on the table here. Since it is greater than 0, so we take the section which is positive. So therefore, the set of value of x is greater than 5/3 and less than 3. Now, we need to combine these two inequalities by using O. So first we use a number line and we label the number line with the critical point, which is 1, 5/3 and 3. For the first inequality, x is from 1 to 5/3. Second inequality, 5/3 to 3. Now since we combine with OR, means the section consists of the arrow line, that is the section we are going to take. So in this case, it is from 1 to 5/3, from 5/3 up to 3, not included this critical point. So therefore, the solution for this modulus inequality is x is greater than 1 but less than 3, then not included the point 5/3. Thanks for watching. I hope you enjoyed this video. If you did, don't forget to give it a thumbs up and don't forget to subscribe. If you have already subscribed, then I am going to see you in the next video. Bye!